In this lesson, we're going to look at simplifying exponential expressions. So, first of all, whenever I see an exponential problem, I make sure before I start that all of the exponents are positive. That just makes it easier to do the adding and subtracting when everything's positive. Because when you have positive and negative numbers, it's easy to make mistakes. It's easy to add when you meant to subtract or subtract when you meant to add. So just start off by making all the exponents positive. And so let's start off with a really simple problem. There's more than one way to do this, but I want to do it by making the exponents positive first, because that's generally the way I approach a more complicated problem. So first, notice that this 2 is the only one with a negative exponent. This 2 has an exponent that you can't see, therefore its exponent is positive 1. So this 2 with the negative 3 exponent will move to the denominator. And we get 2 divided by 2 to the third. Now we can subtract the exponents, because whenever you have top and bottom factors, you can subtract their exponents, as long as the bases are the same. So what I do is, instead of doing top exponent minus bottom exponent, I always do larger minus smaller. That way I always get a positive answer, and I know that that answer belongs wherever I had a larger exponent to start with. And let me show you why that is. If we write out 2 over 2 to the third, it looks like this. And I can cross out a 2 factor in the top and in the bottom. And now, where are the leftover 2's? They're in the denominator. And how many are there? There are 2, because 3 minus 1 is 2. So that gives us 1 over 2 squared. And when I evaluate 2 squared, I get 4. So this is 1 over 4. Alright, here is another one, a little more complicated. We've got 24x to the third y to the fifth over 32x to the seventh y to the negative ninth. Now the only thing with a negative exponent here is this y to the negative ninth. So in order to make that positive, I'm going to move it to the top of the problem. See, that's the only thing that changed, is y to the negative ninth moved from the bottom to the top. Now, the 24 and the 32 are not exponents, so when we simplify them, it's just like simplifying a fraction. They can both be divided by 8, therefore 24 divided by 8 is 3, and 32 divided by 8 is 4. Now for the x's, I've got 7 x's in the denominator and 3 x's in the top. So when I subtract 7 minus 3, I get 4. And because the 7 is the larger exponent, it'll be x to the fourth in the denominator. And we'll also do the y's. Y to the fifth times y to the ninth. Because they're both in the top, we add the 5 and the 9 and get 14. So I've got x to the fourth in the denominator and y to the 14th in the numerator, in the top. And because y and x are different bases, I cannot simplify the 14 and the 4 exponents because the bases are different. And here is one more. So again, I've got a negative exponent, and before I start simplifying anything, I will make that exponent positive by moving it to the denominator. So here's the same problem with x to the fourth positive in the denominator. Now we can simplify 20 over 30. Both can be divided by 10. So we get 2/3. The y's, I have more y's in the top than I do in the bottom. Therefore, when I do 9 minus 3, I get 6. And since y to the ninth is in the top, y to the sixth will go in the top. And on the x's, both are in the bottom. Therefore, there are 16 x's in the denominator. 12 plus 4 is 16. For these next couple of examples, we will look at these problems that have a bunch of stuff in the parentheses and an exponent outside the whole parentheses. So anytime you have an outside exponent, the first thing I want us to do is simplify the inside of the parentheses before you start to worry about that outside exponent. Then you can apply the outside exponent. It's much easier if you simplify everything inside first. And here's our first example. Negative 15 a to the fourth b squared over 35 a to the 10th b to the negative third, all raised to the negative 2. Now I'm not worried about that negative 2 yet. The first thing to do is get this inside all cleaned up as much as we can, make it as simple as possible. And now I see a negative exponent here on the b, so I'm going to, in my first step, take this b to the negative third and put it in the top. This negative 15 is a coefficient, and this negative is not part of an exponent. Therefore, I am not allowed to move the 15 to the denominator to make it positive. That's a very common mistake, but it's a mistake because that rule of move it to the bottom so it becomes positive only works for exponents. It does not work for coefficients. Okay, so here's our first step. Well, I did go ahead and simplify the 15 over 35. Both of these can be divided by 5, and we get negative 3 over 7. Now, the only other thing I did was move the b to the negative third into the top. Now you can see in the next step, I'll simplify the a's by doing 10 minus 4 is 6, so I'll have a to the 6th in the bottom, and both b's are in the top, so we'll have b squared times b to the third makes b to the 5th. But it's still all to the negative 2. Now you know what a negative exponent does is it turns the whole thing upside down. When it's applied to just a variable like it was here, you can think of it as just moving it from the bottom to the top or whatever. But when it's applied to a whole fraction, as we have here, the easiest thing is to think of this negative exponent as turning the whole fraction upside down. So that would look like this. Notice what was in the bottom is now in the top, and what was in the top is now in the bottom, and the exponent has changed signs because when I flip the fraction over, it changes the sign of the outside exponent from negative to positive. Basically, doing the flip uses up the negative sign on the exponent. Notice, however, that for convenience, I left the negative sign that was part of the fraction inside in the top of the fraction. It doesn't really matter where it goes. You could move it to the bottom, you could put it in the front. The most common thing is to leave it in the top, and that's really the best place to leave it. You should never leave it in the bottom, although you can move it there temporarily if you want to, but the best thing is just to always have your negative sign in the top. Okay, now, notice that before we apply the 2 exponent, everything in here is as simplified as it can get. So when I do the 2, it applies to everything in here. I'm going to do negative 7 squared. Negative 7 squared is negative 7 times negative 7, and that is positive 49. A to the 6th squared is a to the 6th times a to the 6th, and that is a to the 12th. Remember your power rule says power to power means you multiply the exponents. 3 squared is 3 times 3, and that is 9. B to the 5th squared is going to be b to the 5 times 2, so that is b to the 10th. Now notice 49 and 9 cannot be simplified. A and b cannot be simplified, and this problem is then as simple as we can make it. Here is another example. In this example, I have a positive outside exponent, so that will save us a step, but I have a negative exponent inside the expression. So the first thing I'm going to do, I guess I'll go ahead and simplify my coefficients, but but I'm also going to move this negative exponent factor to the denominator. Okay, sure enough, 28 and 63 can both be divided by 7. 28 divided by 7 is 4, and 63 divided by 7 is 9. Now, I've taken the a to the negative fourth and put it in the denominator. I've left b to the seventh in the top. I've taken a to the second power, since it's positive, and left it in the denominator. I've taken b to the negative third and put it in the top, so it can be a positive exponent. Now, b to the third times b to the seventh will make b to the 10th, and a to the second times a to the fourth will make a to the 6th. And it's all still to the second power. Now, since this exponent is positive, there's no need to flip this fraction over. We only did that here because the exponent was negative and we had to make it positive. But this exponent is already positive, so we'll just do the second power to everything here. 4 squared is going to be 16. B to the 10th raised to the second is going to be b to the 20th. 9 squared is going to be 81. And a to the 6th squared is going to be a to the 12th. And notice that this cannot be simplified at all, because 16 and 81 cannot both be divided by the same number. And with our variables, we have b's in the top and a's in the bottom, so no simplifying can happen there. For this next example, we're not going to have any outside exponents, but we've just got two factors that need to be multiplied together. So again, I start by making everything a positive exponent. So notice how I'm going to take the y to the negative 12th and move it to the bottom so it becomes y to the positive 12th. Now for 13y to the third, all of that can be thought of as the top of a fraction, and if you wanted to, you could imagine a 1 in the denominator. But we just know that 13 and 2 are both in the top, and y to the third is in the top, and y to the 12th is in the bottom. So when we multiply the tops together, 13 times 2 is 26, times y to the third is still there, and we've got y to the 12th in the bottom. Now to simplify y to the 12th, or y to the third over y to the 12th, we just need to subtract their exponents. So we need to do 12 minus 3 is 9, and since 12 is the larger number, the y to the 9th power will go in the denominator. And this is as simplified as we can make this answer. So let's just recap what we've seen as far as exponent rules and how you know when you finish a problem. In your final answer, you should have each base should appear only one time. You should not have y's in the top and y's in the bottom. If you do, you need to simplify so that you only have a y one place. So each base appears only once. Also, all exponents must be positive. Any negative exponents have to be cleared up. There should not be any parentheses anywhere, because we should work all of those out where they're no longer needed. And there should be no exponents that are equal to 0, because anything to the 0 power is 1. And if you have any factors where the exponent is 1, just do not write that 1 exponent.